This is 3.2, graphing polynomial functions. Here is your essential question. How do you use multiplicity and end behavior to graph polynomial functions? So, how do we find the X-intercepts and Y-intercepts of the following function? Okay, this is something from your previous class, math classes. So, an X-intercept, hopefully you know, you plug in y equals 0. A Y-intercept, hopefully you know you plug in x equals 0. So let's do that real quick. So I'll do my X-intercept first. So I need to plug in 0 for y. And from last unit, we learned about the zero product property. So I'm going to, everything that's multiplied together, I'm going to set it equal to 0. Okay, and then I subtract 2 from both sides, I get negative 2. I subtract 4, I get negative 4. Add 1, and I get positive 1. So I get the points negative 2, 0, negative 4, 0, and 1, 0. And X-intercept, remember, is a point, coordinate, x comma y. You always need to write out the point. Then we can also find the Y-intercept. Plug in x equals 0. So y equals 0 plus 2, 0 plus 4, 0 minus 1. So simplify, I get 2 parentheses first, right? Order of operations. Now we multiply. Kind of hard to read that last one. Let me fix that. 2 times 4 is 8, times negative 1 is negative 8, so y equals negative 8. Once again, an intercept is always a point, so it's 0, comma, negative 8. Right? I plugged in 0 for x, that's why that one's 0. And I plugged in 0 for y, that's why those guys were 0. Okay, so that's a little review of something you should already know. Now we're going to get into the new stuff. The multiplicity of a 0 is the number of times that its associated factor appears in the polynomial. So the 11th degree polynomial, meaning, remember, the highest exponent is 11. That's what degree is. X plus 3 to the 4th, x minus 2 to the 7th. So I only have 2 zeros, negative 3 and positive 2, but they occur more than once. So the negative 3, since it has a power of 4, that factor has a power of 4, it has a multiplicity of 4, meaning it occurs 4 times. X equals 2, that one has a power of 7. So the powers here are the multiplicity, so 7, so that one occurs 7 times, so that would be a multiplicity of 7. If you have an even multiplicity, the X-intercept will touch the axis, meaning it gets right to it and then stops. Another couple words to relate to even multiplicity is a bounce. I like to call it bounce. It doesn't exactly look like a ball bouncing, but it kind of hits and ricochets off, so that's why I call it a bounce. Or, more mathematical term, tangent to. So if it's tangent to, that means it gets to it and then keeps going and does not cross. Okay. Then we have odd multiplicities. That is where we cross the x-axis. And that one's pretty straightforward. You pass through that point. So if your multiplicity is odd, you pass through the x-intercept and just keep going. But if your multiplicity is even, you bounce at that spot. So here's a couple examples. We have both of these have a power of 1, so we're going to cross both. This one has a power of 1, so we cross it. This one has a power of 2, so we bounce on it. Notice what it looks like. It's still a curve. We always curve in and out, kind of like looking at a parabola, but multiple parabolas connected to each other. That's how it should always look. But we get there, touch, and go back. Okay? So, for the functions below, identify each of the listed characteristics. All right. So, we have degree first. So, remember how to multiply these out. We take the highest degree from each parenthesis. So, one thing from each parenthesis, we multiply them together. So, that would be x cubed. So, that's a degree of 3. We also can get the coefficient from it, so we have to think about the lead coefficient. Don't forget about that. I'm just going to add this on the top side. leading coefficient. So that is the number in front of that term we just found, so that would be a positive 1. And we think about our end behavior. You need to have that box memorized. So if I have an odd degree, so if you're looking at your box, I can draw it here. Actually, no, I'm not going to draw it. I'm going to go back and look. So at my last notes, this is what you should be doing. At my last notes, we talked about this box. It's an odd degree with a positive lead, so that's down, up end behavior. Use that box for your homework. You need to have it memorized for the test. X-intercepts with multiplicity. So now I need to find x-intercepts. Remember, we plug in y equals 0. So we go to our original equation, which was y equals, and plug in 0. So 0 equals x minus 3, x plus 4, x minus 1. Zero product property, set each thing equal to 0. X equals 3, x equals negative 4, and x equals 1. Add 3, subtract 4, add 1. Okay. With multiplicity, so we got to take into account each one only occurs once, so each one has a multiplicity of 1. And remember, these are points. X-intercepts are points. So 3, 0 with a multiplicity of 1. That's my first answer. Negative 4, 0, also with a multiplicity of 1. And positive 1, 0, also with a multiplicity of 1. Okay. Now your y-intercept, remember that is x equals 0. So y equals 0 minus 3, 0 plus 4, 0 minus 1. Follow your order of operations. So it's negative 3, positive 4, negative 1. Negative times a negative makes a positive, so it's going to end up as positive. 3 times 4 times 1 is 12. Y equals 12. And that is this. Notice that y-intercepts do not ask for multiplicity because they will always cross through. Only x-intercepts do you have to worry about multiplicity. How many distinct x-intercepts? So this seems like the same question as degree, but it's actually not. Distinct x-intercepts means how many individual x-intercepts are there? So 1, 2, 3. I have 3 x-intercepts. Okay? The next question, how many roots? If they ever ask for roots or zeros, oh, that's not how you spell zeros. There we go. If they ask for roots or zeros, it is the same as degree. It is always the same as degree. Okay, so in this case, my degree was 3, so my roots are 3. If they ask for roots or zeros, it's the same as the degree. If they ask for distinct x-intercepts, it might not be the same, which we'll see in the next one when that's the case. Okay, so the next one, example 2, we have our equation. It says degree, so we take from each piece, we take the highest power, right? Each parenthesis, and then the one in front, that's the GCF. We also have to take that into account. So that would be x squared times x, which is x to the 4th. So it's the degree of 4. Once again, don't forget about the leading coefficient. Which is, once again, positive 1. So it's a 4th degree, even degree with a positive lead, and behavior is up, up. You can look at your table if you need to see it. All right, x-intercepts, set y equal to 0. Remember, f of x is the same as y. X squared, x plus 3, x minus 8. Set each multiplied piece to 0. X squared equals 0, x plus 3 equals 0. And x minus 8 equals 0. We would square root both sides, so I get x equals 0. Subtract 3, x equals negative 3. Add 8, x equals positive 8. With multiplicities, don't forget that. So my first point is actually 0, 0, but it has a multiplicity of 2. Then I have negative 3, 0 with a multiplicity of 1. It only occurs one time. This one's 2 because it occurs twice. X is squared. This one is to the 1st power, so it only occurs once. And then 8, 0, which also has a multiplicity of 1 because it only occurs once. Y-intercept, notice it doesn't ask for multiplicity because we don't worry about multiplicity for this. So y equals, remember, f of x and y are the same thing. So 0 squared times 0 plus 3 times 0 minus 8. So I end up with 0 times 3 times a negative 8. What is 0 times anything? 0. So there we go. 0, 0 is my y-intercept. How many distinct x-intercepts? 1, 2, 3. I have 3 distinct x-intercepts, 3 different points. But how many roots are there, right? Roots or zeros matches the degree. There are 4 roots because this one, 0, 0, occurs twice. So it's 4, which matches our degree every time. Okay. Now we're going to actually, those same functions, so the first one is the same function. The order doesn't matter. This one's x minus 1, x plus 4, x minus 3. That, if you look at example 1, which was x minus 3, x plus 4, x minus 1, they are the same thing. The order doesn't matter because we're multiplying. So I already have all the pieces. Instead of going through and finding all the pieces again, we're going to sketch the graph using all of these things. So we have our in behavior. We always need the in behavior, which is down, up. We need our intercepts, which was 3, 0 with their multiplicities, negative 4, 0, and 1, 0. We need our y-intercept, which was 0, 12. And that's it. So I always start with the x-intercepts. So 3, 0, negative 4, 0, and positive 1, 0. And we got to think. Since they're all a multiplicity of 1, that means I'm going to pass through each one. We start down. So wherever my furthest left point is, I'm going to put a little thing down here. And I end up. So wherever my furthest right point is, I'm going to put a little stop here. So I remember down to up. And then I have my y-intercept, which is positive 12. You do not need to put 12 tick marks. Just kind of go up about where that would be and label it as 12. Done. Okay, so I have to go cross every point and have the correct in behavior. So here we go. It is just a sketch. Put arrows on the end always, and you have it. Notice I am not having a sharp turn ever. You can't have sharp turns. You can't come to a point. It is a nice curve. Should look like parabolas connected to each other every time. All right, next one. Fortunately, we have to go through the whole thing now. All right, so first we take the leading term from each piece. Don't forget the exponent. So it's 2 times x squared times x. So that's 2x cubed. That is my leading term, 2x cubed. So it has a positive 2 lead coefficient with an odd degree, down, up. They're going to change depending on the problem, so don't think it's always the same. Okay, now we need our x-intercepts and our y-intercepts. So we actually have to find them now. Okay, a lot of people get confused with this coefficient without an x. If there's no x in front, when can 2 equal 0? Never. So I'm not really worried about it. So I set my other things equal to 0. I guess I don't need parentheses for that second one. Okay, so this one I square root both sides, so I get 0, and then I subtract 3. This one I add 2, and so I get my 2 x-intercepts. Negative 3, 0 with a multiplicity of 2, it occurs twice because of that thing. And 2, 0 with a multiplicity of 1, it only occurred once. Okay, and finally we need our y-intercept. So I set 0 equal to x, so y equals what is it? 2 times 0 plus 3 squared times 0 minus 2. So I get y equals 2 times 3 squared times negative 2. So that is 2 times 9 times negative 2. 2 times 9 is 18 times negative 2 is negative 36. So 0, negative 36. And so I start with my x-intercepts. So I get negative 3, 0, but remember that one's going to bounce. That's an important trait. Positive 2, 0, and negative 36, way the heck down here. We get our y-intercept. And we need our end behavior, so it starts down, so my leftmost point go down, my rightmost point I go up. And be careful, make sure you bounce. Oops, sorry, I should not have bounced at. There we go. Nope. Can't make it look good. Here we go. It doesn't have to look good, by the way. It can look however it wants, but for your notes, I want it to look good. So there you go. It'll look something like that. Okay. And once again, notice it's nice curves. They look like parabolas, kind of connected to each other. Make sure that's always what it looks like. All right, now we have the last problem. It says, given this sketch, okay? So I'm going to change colors just so it's not confusing. So we take the leading coefficient from each thing. So this one ends up as negative 2x to the fourth. Negative 2x squared times x squared is negative 2x to the fourth. It's negative and even, so down, down. My x-intercepts, so I plug in 0 for y. So 0 equals negative 2x squared, x plus 2 squared. Remember, it has an x in the front. We have to set it equal to 0. It's when it's only a number. Do we not? So I divide by negative 2, and I still get 0. Square root, and I get 0. So I get 0, 0, but pay attention to the power. Multiplicity of 2. This one, I square root both sides. And then subtract 2. So I get negative 2, 0, and multiplicity of 2. Again, they both bounce. They will both bounce. Okay, and finally my y-intercept, which I still need to get. So y equals negative 2 times 0 squared times 0 plus 2 squared. So I get y equals negative 2 times 0 times 2 squared, which is negative 2 times 0 times 4. What is 0 times anything? 0. So 0, 0. Remember, we don't have multiplicities for y-intercepts, only x-intercepts. Okay? So 0, 0 is both my x-intercept and y-intercept. So this one will bounce because of the x-intercept. And negative 2, 0. All right? So we're just graphing y equals g of x, by the way. And we are down, down. So start low, leftmost point, I'm low. After my rightmost point, I am low. So I'm going to go, bounce, make it a little parabola, bounce. And it'll look like that. Once again, notice they are curves. They should look like little parabolas all connected together. Always have to have curves. And it says, label the points. So I need to label my x and y intercepts. So I'm going to label them on the graph. Negative 2, 0, and 0, 0. There we go. Done. Next one. So that's g of x. That's my focus, that graph. Next one is telling me to shift. It's in parentheses, so this is right 4. So I'm going to take each one of these points and shift it right 4. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, everything else is the same, so it's still low, low. So bounce, bounce. That's my new graph. Sorry. There we go. It wants me to label my relative maximum. So remember, relative maximum is where you're increasing before and decreasing after. Any point that's increasing before and decreasing after. So this point right here is one relative max, and that's at positive 2, 0. And then this one is increasing and decreasing, and that's at 4, 0. Okay, so you need to know the terms from last unit, like relative max and min. You need to know how to shift with all of our graphs. It's going to come up every unit, really. Okay, so I have a negative on the inside. So that's a reflection over the y-axis. Okay, so reflect over the y-axis. My point that was on the y-axis stays the same. My point that was on the other side, so it was 2 left. Now I go 2 to the right. It's still down, down, because I'm reflecting over the y-axis. So I graph. And there we have it. I need to label my x and y intercepts, so I have 0, 0, and positive 2, 0. Done. And this last one, this is down 2. It's not in parentheses. And remember, we're always going back to our original functions. We're not flipping or shifting. So I always have to go back to this one. So I'm going to move each point down 2. Since I'm only going down 2, I'm actually going to put the little tick marks just to make my life a little easier. Something, a guide to follow. Okay. So I moved down 2. So this one went down 2. This one went down 2. Still the same in behavior. And there we have it. It tells us to label our y-intercept only. So our y-intercept is right here, which where it crosses the y-axis, and that's at 0, -2 now. And there we have it. The shiftings, room reflections, and finding this in behavior, x-intercept, and y-intercept. Okay, so you can write your 3-sentence summary.